Hello, we're beginning chapter 3. If you've only heard of an electron as a dot in the atom, you're going to find this chapter very interesting. Until this point, we've talked about atoms, how they have nuclei that are composed of protons and neutrons, and that electrons are outside of the nuclei. We did a lot of electron counting and proton counting in the last chapter, but we are especially focusing on electrons and the energy associated with the electrons in this chapter. We're going to look at where they are, what kind of area they look like they're in. Those kinds of questions are the ones that we're going to be answering to the best of our understanding at this point. As before, the first page is your math reference page for chapter 3. Notice you have equations in the very top section. You will need to know all these equations. The highlighted colors are constants that you will need to know because you will use them over and over. So that constant c is the speed of light. It goes into two different equations. And then also this h is in two equations, right, like that. This letter is a lambda, and you're going to learn more about it, but it represents a wavelength. And in this equation, this lambda has to have the unit of a meter. If the problem gives you to you in a different unit, you have to change it to meters to be able to use this equation. That's true over here too. This is supposed to be a meter. And then the other section right here, this is actually a Greek nu. It's not to be thought of as v velocity. It's completely different. And this is frequency. You know, frequency in terms of high pitch can be very painful, or high vibration can be very powerful. That's what frequency is. And the units of frequency is seconds to the minus 1. So what that means is we're saying 1 over a second is a frequency. What it really means is how many frequencies occur in a second, or how many waves pass by in a second. We'll talk more about it. Another unit that is used for frequency is hertz. You're probably familiar with that with the radio. So also over here, this is seconds to the minus 1 or hertz. That's the same thing. The constants are listed below. Be very aware of the exponents, whether they're positive or negative when you're putting them in the calculator. Highly recommend using the E key, the exponent key that represents times 10 to the in both of these cases. If you need help finding it, you can meet with one of us after class. And just as a reminder, if you didn't catch it before, I was just saying here are all of the different units. Energy in this equation is going to come out to be joules. Here are some conversions that may come up in this chapter. You'll see calories and joules in chapter 9, but they also sometimes happen in this chapter. Electron volts are a unit of energy, and this is how you get from a joule to an electron volt. And then we talked about moles and Avogadro's number. Well, there's that many photons, which is like a little pocket of energy, pocket of light, and or a discrete amount of it is maybe how you could say. And so just so you know, there's that many of them in a mole also. If you don't know a lot about wavelengths, this side is the unsafe side, and generally this is the safer side. You can see where different amounts of energy fall in here. You know, obviously, that cosmic rays are not great for you. You do not want to have thousands of PET scans in a year. And you know that X-rays, if you have over a certain amount, are not good. Then we have our dental curing, which falls right around in the ultraviolet spectrum. Then we have visible light. Do you see how small visible light falls in the whole range of all of the different lengths of wavelengths? We've got our night vision, remote controls, wireless data, radar, cell phone, AM, radio. And over here we have our microwave oven. And a lot of people wonder about microwave ovens because we know they're not safe. And that has more to do with what the microwave oven does. It rotates molecules in a way that it causes a lot of energy to build up in the cells. There's more on this in Dr. Bean's video. I'll point out where it is. So you'll notice that it makes sense too that this end of the spectrum, ultraviolet, and that's kind of the violet. If you're thinking of Roy G. Biv, it's like backwards Roy G. Biv. And then over here, You've got your red end of the spectrum, and here's your infrared. This lower section scale matches with what you're seeing up here, so that you can kind of think of this as one whole unit in a way. So the low energy side is going to be over here. This is low energy. This side is high energy. Frequency is how many passes in a certain period of time per second. So let's say that we're talking about this unit of time. So you can see where on the left you have like 3 that pass by. And then if we take this over here to the right-hand side, you can see that in that same period of time, we only have half of a wavelength. So the time is what's constant, and it's how much passes by in that period of time. So frequency on this end, we would say that it's high because there are several waves that pass. And on this end is low because there's only part of a wave that passes. And the frequency, remember, is that funny little nu symbol. And then wavelength, this is large or small. So this is the length of the wave. And so, for example, right here, this wave has a very short length. This wave has a very long wave length. So it's the length from peak to peak, trough to trough, if you want to do the middle, but it's that length. So over here, this is a long wavelength, and this is a short wavelength. A lot of times this word changes to being a, people use low wavelength, and they really shouldn't, but because these two we're talking about in terms of high, people will call this low, or they'll call it small. It's technically a short wavelength. And then over here, you will also see the terminology low or like large, big. It's a big wavelength, a large wavelength. The best word is long, but you'll see all 3 used. Lastly, we have amplitude, and amplitude is how high something is. So right here, that is our amplitude. So you'll notice all of these waves all have the same amplitude as drawn. If you think of amplitude in sound, because sound has waves, if you were to take the amplitude, keep everything else the same, the frequency, a higher amplitude is a louder sound. When you're talking about light, it's a brighter light. So this is a larger amplitude. And we already talked about the units for energy and frequency and wavelength. We won't have you do calculations with amplitude, but you need to understand what it is. So as we move into electrons, this playlist is helpful for giving you background information if you don't know very much at all about waves, if you haven't ever had any kind of a physics class, or you just never covered it much. This is a really interesting playlist. It goes through some of the different things that were being dealt with. Like they were having some experiments with electrons coming out as electrons being particles, but then they also had other experiments where they were acting as waves. And this playlist has some really great YouTubers in it who explain the experiments in a way that makes sense, like using a watermelon. So they're really, really great.